Hello my dear students, I am here Mr. Abdel Nasser and my group to discuss about the geometrical lesson which is applications on vectors. We have here applications on vectors. We have two applications in vectors. The first one is geometrical application, okay, and the second one is physical application. Now we will study geometrical application. Okay, what about geometrical application? We depends on two basics. The first one is if we have a vector AB and another vector CD like that, AB, the vector AB equals K, the vector CD. If we have a vector AB equals K multiply, K is a real number, by the way. K here belongs to R. It is a real number. If we have the vector AB equal K multiplied by the vector CD, then we will deduce that first AB is parallel to CD, okay, as a line segment, and also the magnitude of AB like that equals the absolute value of K multiplied the magnitude of the vector CD. The norm of a vector is its magnitude or its length, okay. And the second basic, the triangular vector rule. If we have a triangle here ABC like that, and we have a vector in direction from B to C and direction for the vector BA here is the sum of BC and CA. So we write from this the vector BC plus the vector CA equals the vector BA. Okay, these are the two basics that we will depend on geometrical application for applications on vectors. Now my dear students, we will go about, we have here a triangle like that, and this triangle called ABC as example, and we have two midpoints here. This midpoint is X of line segment AB, and this is the line segment, the midpoint of AC, which is Y. And from our studying before in prep 1, we said that if X midpoint of AB and Y is a midpoint of AC, then we deduce that XY is parallel to BC, and also the length of XY equals half the length of BC. We deduced these two rules from the two midpoints, okay. But why is this? We will use the vectors. The given here is X midpoint of AB and Y is midpoint of AC. The required to prove, or the request to prove, is XY parallel to BC and XY equals half BC. Okay, the proof itself, the solution, we will use the vectors. Where we will use the vectors? We will use the vectors in this triangle first, the smallest triangle, triangle AXY, and we will concentrate in XY here. The vector XY equals what? The vector XY here equals the vector XA plus the vector AY. And we call this number 1, the equation number 1. And in second triangle, which is the big triangle ABC here, we will concentrate about BC. So the vector BC here equals the vector BA plus the vector AC, and this is the equation number 2. From the two equations, we know that when x is the midpoint of AB, then AX equals half AB, of course. So we can deduce substitution here, substitute about XA. We have XY here. XA is what? Is half the vector BA, and AY equals half the vector AC, and by taking highest common factor, which is half here, half BA plus AC. What is BA plus AC? The vector BA plus AC is equal to the vector BC, so it's half the vector BC. So now we have a very important deduction here, that the vector XY equals half the vector BC. From this, we will deduce what? We will deduce that XY is parallel to BC, and also XY equals half to BC. So we have two things we have deduced from this. We deduce that XY parallel to BC and XY as a length equals half BC. From where? From the two triangles. Triangle AXY, we have the vector XY here equals the vector XA plus AY, and from triangle ABC we have the vector BC equals the vector BA plus AC, and we substitute about the vector XA by half the vector BA, and the vector AY equals half the vector AC, and we will take half as a common vector here, so BA plus AC, we know that it's BC. Okay, so XY, we do that, XY parallel to BC, and XY as a length equals half BC. Okay, so my dear students, let's move to another question. We know that you may be surprised about the solution. Okay, we have another question here. If we have a parallelogram like that, we call it A, B, C, D, and the given is that DC this line segment parallel to AB, DC here is parallel to AB, and also DC equals AB, and the required to prove is that if DC parallel and equal to AB, then ABCD is already parallelogram, or we will deduce that DA also here is parallel to CB and DA also equal to CB. Okay, we will make a construction here. We will join construction, join CA, and we know that required to prove that DA is parallel to CB and DA equals CB. The proof is, which is the solution, we here have two triangles. We will use each triangle from the triangular rule of vectors. First, we will use the triangle DAC. In this triangle, we will concentrate about the diagonal AC as a vector. We have the vector AC here equals what? Of course, the vector AC equals AD plus the vector DC. This is the first equation. And in the other triangle, which is CAB, we have also the same vector AC here equals AB plus the vector BC. So the vector AC equals the vector AB plus the vector BC. From 1 and 2, we will deduce that we have the left hand side here is the same. So the right hand side, of course, equals the right hand side. So the vector AD plus the vector DC equals the vector AB plus the vector BC. Okay, and from the elimination rule or property, we know that DC equal and parallel AB. So the vector DC, of course, equals the vector AB. So we can cancel the vector AB with the vector DC. The remainder here is the vector AD equals the vector BC. The vector AD here is equal the vector BC. What it does mean? It means that AD is parallel to DC as the line segments, and AB, okay, AD here parallel to the vector BC, and the vector AD also equals the vector BC in length or in magnitude. So we have here the required to prove that DA parallel to CB or AD parallel to BC, doesn't matter, and AD equals BC. So of course ABCD is a parallelogram. Okay, the first question or the beginning of the question is, we have here from the various studying from prep 1 that if DC parallel and equal AB, then it is parallelogram. Why is it parallelogram? It is parallelogram because each two opposite sides are parallel and each two opposite sides are equal also. And we have here, by using vectors, we deduce that it's yes. If we can prove that two opposite sides are parallel and equal, then it is a parallelogram. Okay, let's move to another question. Secondly, we will use vectors to speak about some physical rules. We know that if you sit in a car and you look around you, you will see some cars or some motorcycles move beside you in the same road or in the same direction or opposite direction. So what questions or what application, what physical application in vectors here? So we will discuss about physical applications in vectors. What physical applications on vectors? We will discuss about the relative velocity. I know, my dear students, that you have idea about relative velocity in physics, so it will be easy for you, inshallah. We will talk about, if we have a car here, we call it A, and this car moves in this direction. Okay, say the unit vector of this direction is E, which is positive. Okay, and imagine yourself that you sit here in the car, even you are the driver or you sit beside the driver, and you see another car here, B, maybe in the same direction, and it is take the same E and its positive direction, or it take the opposite direction and this will be give it as a negative value, okay, of E. It will be negative E, and we will deduce the rule, or we will take the rule that if we have the car A and the car A has the observer here which sit here and look at the car B, we will talk about the rule that VBA means that the velocity of the car B related to or relative to the car A, because the car A here is the observer, equals VB minus VA by its order. VBA equal VB minus VA. Okay, here this velocity means that the observer feels that himself is fixed, or its velocity equals 0, and feels that the car B moves with the sum of the two velocities VBA, may be sum or difference. Okay, to understand well, let's move about an example here. If we have a car A, okay, this car moves in direction, and we will get the direction is positive. A car A moves in a straight road with velocity 80 kilometers per hour, and a car B moves on the same road with velocity 60 kilometers per hour. this car B moves in the same road with velocity 60 km/h. The question is to find the velocity of the car A with respect to the car B. So the car B here is the observer, and its direction is the positive direction. Okay, and we will write VAB. Notice that we will fix B, the observer, is the last car to be easier for you, and we will fix also the direction of the observer B is the positive direction, and its velocity is 60 km/h. Okay, so the observer here VB, so we write the velocity VAB. We will fix the observer in the end. So the rule is equals VA minus VB. Okay, what is VA? VA here is the velocity of the car besides the driver who watch it. So VA here is 80 km/h minus VB, which 60. These two cars are in the same direction. Okay, so the observer in this direction, which is positive, by 60 km/h, and the car A moves in the same road in the same direction with 80 km/h, and it is positive also. So VA minus VB equals 80 minus 60 equals 20 km/h. So the driver here feels that the car A moves with 20 km/h in the same direction of it. But what about if they have the opposite direction? We have the car B, which is the observer, and moves here with positive direction by 60 km/h. And the car B here moves in the opposite direction, which is negative here, by 80 km/h. So what is the velocity of the car A related to the car B? VAB, and concentrate about B, it's the observer, equals VA minus VB. Here VA equals what? Okay, sorry, we have A here. Here B is the direction of the observer here, and the car moves with 60 km/h in the opposite direction, the positive direction of E, and the car A moves in the opposite direction by negative E, and we will put negative 80. Why negative 80 here? Negative 80 because it is the opposite direction of the observer. Observer moves in this direction, and the car A moves in the opposite direction, so we will give it negative 80. So VA here equals negative 80 minus VB equals negative 60 equals 60. So the answer will be negative 140. What about the meaning of this negative? This negative means that the car B, which has the observer, the driver here, feels that the car A moves with velocity 140 km/h in opposite direction. He feels that the car moves with more velocity because it moves opposite to him. Okay, we have also another question for you. It's very enjoyable that from mathematics we study the application, which is physics application. So we have here a motorcycle A. Okay, this motorcycle moves with velocity 50 kilometers per hour. Okay, moves in this direction. We will consider it positive, with 50 kilometers per hour. What about it? And feels that a car B moving in the opposite direction. Here the motorcycle driver, okay, or rider, feels. It's very important to feel. What the meaning is of feels? Feels that another car B, like that, moves in the opposite direction by velocity 110 kilometers per hour. B here means the opposite direction. Opposite means that will get negative 110, because the rider of the motorcycle here moves in this direction, which is we consider it positive, and it's 50 kilometers per hour in this direction, and he feels that the opposite direction, the car B moves in the opposite direction with 110 km per hour. So 110 km per hour, is it the actual velocity of B? No. Because what? Because he just feels that. Feels that means the rider of the motorcycle is A, so VBA. A here is the rider of the motorcycle because he is the observer, equals VB minus VA. Okay, and here VBA equal VB minus VA. What is the number negative 110? Is it VBA or VB or VA? VA here is 50, so we substitute about VA by 50 kilometers per hour. This is minus, which is this one. And the rider of the motorcycle feels that the car moves with the 110 kilometers per hour. So negative 110 because of opposite direction, put here. We know that if he feels that, so it is not the actual velocity of B, it is the relative velocity of B related to A. And we have here VB is unknown, and by solution to this one here, VB equals negative 110, and transfer negative 50 to B plus 50. So VB here equals negative 60 kilometers per hour. That means that the car B moves actually in opposite direction with velocity 60 kilometers per hour. And we have here the answer now. Okay, we can take a break now. We will complete now the applications. Let's return again to geometrical applications here. If we have a triangle like that, triangle A, B, C, and we have a median. This is the midpoint here, say it D, and AD here is the median. And we know about the intersection point of the medians. If we have another median here and third median here, they will intersect at the point M from the previous studying. And we know that AM here equal double MD. We have known that the point of concurrence or the point of intersection of medians divides each median by the ratio. Okay. This part is twice is part. Okay. So let's go to how we can deduce that AC, the vector AC here, plus the vector AB equals double the vector AD. Okay. We have here two triangles. This triangle, we know that AD, the vector AD, equals the vector AB plus CD. This is number one. And this triangle, the vector A also equals what? Equals the vector AB plus the vector BD. And this is the equation number 2. Okay. By adding these two equations, we will find that AD multiply 2, because AD plus AD equal 2AD, equals the vector AB, this one, plus the vector CD, plus the vector AB, plus the vector BD. Okay. We know that the vector CD equals the vector BD, but in the opposite direction. So if we have CD and BD, one of them equal negative the other, so we'll cancel it. So where is BD? BD here, cancelled with CD, and the remainder will be the vector AB plus the vector AC. Okay, here AC. Okay, so the vector here AC plus CD equals AD. Okay, the vector AB plus the vector AC equal double the vector AD. You have a telephone? Okay. الو السلام عليكم.
وعليكم السلام. معلش يا استاذ، انا اسف يعني، انا عربي بس عندي سؤال في الرياضه، انا اسف.
اتفضل يا فندم.
هو دلوقتي اذا كانت صفر درجه اصغر من سيتا اصغر من او تساوي 360، فان مجموعه حل المعادله جاء 2 سيتا زائد 30 درجه.
معلش تاني لو سمحت.
حاضر. اذا كانت صفر درجه اصغر من سيتا اصغر من او تساوي 360، فان مجموعه حل المعادله جاء افتح قوس 2 سيتا زائد 30 درجه تساوي.
لا بالراحه بس، بالراحه يا استاذ، بالراحه.
ماشي.
طب ده حضرتك ده تريج. احنا النهارده الموضوع بتاعنا بنتكلم عن فيكتور، بس استاذنك يعني ممكن حضرتك تبقى
كلامك بعد الحلقه
تدي كنترول سؤالك وهجاوب عليه حضرتك المره الجايه، لان ده سؤال بيتكلم عن الموضوع غير اللي بيتكلم فيه الحقيقه، عشان بس ما اعطاش الولاد. اوكي. My dear students, let's move again to our lesson. Okay. we have here the same triangle A, B, C, and we have midpoint here. Okay, and we have M is the point of concurrence, or the point of intersecting of the medians. Okay, here we have M, and we know that the division is 2 to 1. If we have the points A here has the coordinates 2 and 1, and C the coordinates 6 and -3, and this coordinate 1 and 5. Okay, and find using vectors. Find, the question is to find using vectors the coordinates of M. M here may be, we call it X and Y. Okay. Okay. We here have, we know that AD or AB, the vector AB plus the vector, divide AD here into 3 equal parts. We have AM equal 2 parts and MD equal 1 part. So when we compare between AM and AD, and or starting with AD, it means 3, and AM means 2 AM. Okay, and we know that AB plus AC here equal double AD. So we will get AB plus AC equals 2 multiply what? Multiplies 3 over 2 AM. So by multiplying, 2 cancelled with 2, and we will deduce that AB plus AC equals 3 AM. Okay, we know that if we have AB and we would like to find the length of AB, we will put B minus A, and AC means C minus A equals 3AM, which means M minus A. Okay, and by multiplying we have here 3M minus 3A. Okay, we have here B minus A plus C minus A also. Okay, and we have -3A here. By transfer -3A in the other side, we will get positive 3A, and we have here -2A, so the answer will A also, only A, plus this B plus this C. So we have these equals what? Equal 3M. So we have important deduction here, that A plus B plus C equals 3M. So we can deduce that M equals 1 over 3 A plus B plus C. Okay, and by putting numbers here, M will equals 1 over 3 A equal what? A here equal 2 and 1. Okay, 2 is the X, and B equals 1 and 5, and 1 is the X, and C equals 6 and negative 3, and 6 is the x is the 6. So we can move to 2 plus 1 plus 6, 2 plus 1 plus 6, and y equals 1 plus 5 plus negative 3. Okay, so the answer will be here 2 plus 1 equals 3 plus 6 equals 9, 1/3 9 equals 3, and 1 plus 5 equals 6, 6 minus 3 equals 3, 1/3 3 is 1. So the final answer that the m here, coordinates of m, is 3 and 1. Okay, let's make a brief for this one. My dear students, it's a long question, but we can make it easier by this rule. So concentrate with me. If we have a triangle ABC here, and A will be x1 and y1 coordinates, B is x2 and y2 coordinates, C is x3 and y3 coordinates. From the previous example, we have deduced that if we want to find the m here is the point of concurrence or the intersecting point of the medians. So m equals all x1 plus x2 plus x3, all of them over 3, and of course y1 plus y2 plus y3 all over 3. Okay, so we will add x1 plus x2 plus x3 and divide them by 3, and also add y1 plus y2 plus y3 and all of them over 3. Okay, so if we have this A equals 2 and 1, and B equals 1 and 5, and C equals 6 and negative 3, we can directly find the vector m or the coordinates of m by applying this rule, which is 2 plus 1 plus 6, which is 9 over 3, and 1 plus negative 3 plus 5, which is 3 over 3. So the answer will be the coordinates of m or the vector m equals 3 and 1. And now we have deduced the important rule for us. Let's move to another question. We will move about parallelogram also. We have studied before that if we have a parallelogram, then the two diagonals bisect each other, but without proof. Now we will use vectors to prove that the diagonals of parallelogram are already bisect each other. So if we have a parallelogram here like that, A, B, C, D is a parallelogram. Okay, and we have already diagonal here is DB, and we have a midpoint here called M, and as a constructing we will join AM. Why didn't we say AC directly? No, it's just AM because we join A by M and also MC, and if we deduce that A, M and C are on the same straight line or collinear, and so we will deduce that AM equal MC when we deduce that AM equal MC, then the two diagonals already will be bisect each other. So we will concentrate about two triangles, ABM here. We have a triangle here and the triangle DMC. Okay, and we will concentrate our talking about the vector AM. The vector AM here from the triangle AMB, AM as a vector equals what? AM as a vector equals the vector AB plus the vector MB. Here AM equal AB and BM. This is the equation number 1. By using the other triangle, which is triangle DMC, we will deduce that the vector MC, okay, notice that I have chosen the first triangle the vector AM, and the second one is the vector MC in the same direction. Okay, the vector MC equals what? The vector MC equals MD plus DC. The vector MD plus the vector DC, and this is the equation number 2. By comparing these two equations, we will find what? Now the left hand side is the vector AM and the vector MC. What about the right hand side here? The right hand side here talk about AB. Where is AB? AB here, and DC here, DC and AB, because it is a parallelogram, so they are equal in length, and as the vectors they have the same direction because they are parallel. So the vector AB of course equals the vector DC. Okay, this one equals this one. What about BM and MD? BM here equals the vector MD because we have already talked about the midpoint here. Okay, so and they have the same direction. BM equal MD as vectors, so this one equals this one. So right hand side equal right hand side. Of course left hand side here, which is left hand side equal left hand side, which is AM, the vector AM here, of course equals the vector MC. Now we have deduced that AM equals the vector MC, and we have M as a common point. Okay, when a vector equal another vector, then we consider them parallel, but when we have the point the common point, then they will be in the same straight line. So A, M and C are collinear, and AM equals MC. So the diagonals here, diagonals which is DB and AC bisect each other. So again, what is the request of the question? We have here a parallelogram. This parallelogram have diagonals AC and DB, and the required to prove is to deduce that the two diagonals AC and DB bisect each other, and we have here DB is the diagonal, and we consider that M is the midpoint of DB, and we join AM and MC as a construction. We didn't say AMC or AC. We just join AM and MC at as to consider line segments or to separate line segments. Okay. Now we have deduced that the diagonals bisect each other. Okay. Let's move to the last question. We have the last question for you, my dear students. Okay. We have here a rhombus, a trapezium like that. This trapezium called A, D, C, B. Okay. And we have AD, of course, parallel to BC, and AD called the vector M, and the vector AB, concentrate about direction, called the vector N. Okay. And we have DB as the diagonal here, and he gives us two things, that AD parallel to BC, this is the number one. Number two, he gives you that BC equals 3AD. Where is BC? BC is a vector equals 3 times the vector AD. And the request is to express, required to prove, to express the vectors BC, AC, BD, and DC in terms of N and M, the vector N and the vector M. The solution will be, let's concentrate about the triangle. Let's first talk about BC. Where is BC? BC here is this vector and have the same direction as AD, and we would like to express it in terms of M and N, or M only, N only. And he gives you a very important given that the vector BC equals 3AD. So we have the vector BC already equals 3AD. That means that the vector BC equals 3M. This is the first one. The second one is AC. If we join AC here, the vector AC in triangle ABC, triangle ABC, we will deduce what? From the triangle ABC, and we have the vector AC, okay, equals AB plus BC. Okay. AB here is the vector N, but in the opposite direction, so it's negative N. Okay. Okay. AC here equal CB plus BA. So BA is negative N plus CB equals negative 3M. Okay. BD, okay, BD here equals BA plus AD, BA equal negative N plus AD with M, and you can deduce DC yourself. Okay, My dear students, we have finished now our lesson for today. Until we meet again next Friday, inshallah. Happy day and safe. Be safe.